All right, class, welcome to week two. We're going to start getting into kind of more the realities of what biological anthropology is and outside of the housekeeping stuff. Um, Again, a fair amount of you have emailed me about specifics. I'm going to go through a little bit of housekeeping. So the big one is that you actually um, focus on the modules tab on the side to make sure that that's where the work is found. The other thing is to make sure that you watch the lectures because a lot of kind of important information for the week will be discussed in the lectures. For instance, this week I am definitely getting into kind of the research paper and what that looks like, just to give you guys enough time moving into the semester. We're going to get into the scientific method at first, and then dating techniques, which you guys will probably want to research a little bit more. I've put a video on here about radioactive or radiocarbon dating. But yeah, so I'll briefly touch on a lot of this stuff and go into kind of more details around certain things. And again, continue to email me if necessary. What else have I posted on there? I think that's it. Anyway, just stay in contact if necessary. I can throw up alternative discussion board for people who kind of want to get information from classmates rather than maybe even me, because I know that some students like to do that. It creates more of a classroom feel. Anyway, moving into week two, kind of the areas of review are the four subfields of anthropology. What is physical and biological anthropology? What do they study? If you can answer those questions, you're good on week one, right? The four subfields of anthropology are biological or physical, same subfield. Physical, again, is more the traditional terminology for the subfield that you're studying currently. The second would be cultural. The third is archaeology, and the fourth is linguistics. Sometimes there's a fifth, but it's applied anthropology, and I'm not going to test you on applied. All right. Biological anthropology, again, we're going to get into the scientific method. Biological anthropology is much more hard science than the social science that is cultural anthropology. But that being said, it's a hard science in terms of how it does its kind of laboratory testing and wanting to quantify data. But I would still say that this field in general has a certain level of interpretation involved. And if you're kind of a critical analyzer like myself, then you'll probably come across some information today that has some of those elements. One of the videos that I posted is about early hominid evolution, Aurora tungenensis, and that find is important because it kind of backed up the date of bipedalism among hominids. But I really want you to focus on the scientific method in that video, even though it's giving you a lot of information. We're going to cover that stuff at the second half of the semester. I kind of like to front load some of the stuff, but I would really like for you all to kind of pull out the scientific method in that video. They do a good job of explaining how kind of they come across, they observe something and then they start asking questions like, oh, how old is this? And then they start actually doing the testing. And then what is the process? Is it just that the scientists proclaim that they found something? Does it go to the press right away? Do other scientists from other schools and or countries, universities have to study that and make sure that it's accurate in terms of their dating and what they're actually looking at? Pull that kind of information out in terms of the scientific process of that video. The Darwin video is extremely interesting, fills in a lot of holes. If you want to watch the whole thing, it's almost 2 hours, but I recommend watching the first half just to kind of get a sense of who Darwin was, what was the impetus of his kind of journey on the Beagle to kind of Tierra del Fuego and the Galapagos, and then kind of what on the start of kind of the next section after his life stuff. What is it that he's discovering and kind of making observations around. All right. So jumping right in, the scientific method. A lot of us have been exposed to this, if not all of us, over and over and over again because we take science every year. However, it might be a little bit different kind of coming from this subfield in terms of how we go about doing things. So the first level of the scientific method is to make observations. The next is to think of interesting questions, right? Like, so again, in the video, you'll say an individual kind of makes an observation, finds some teeth in the ground, asks interesting questions, which is like, where do they come from? How old are they? Who do they belong to? And then starts formulating hypothesis, right? Like, oh, I think these are really, really old because the teeth don't look like human teeth. And then you start kind of making testable predictions. And that could either be, is that and when you test those things um, and gather data, you're trying to figure out where to lump things, how old they are, and then you're going to actually use laboratory equipment to see if you can kind of get a date on those things. Sometimes certain elements hold up very well. And after you kind of test your data, you're either going to do one of two things, which is one, reject your hypothesis and then kind of go back to the starting board, maybe create a new hypothesis. If in general the data and the hypothesis looks to be correct after a bunch of different tests, which would say that the validity of your test is valid, or I guess that was redundancy, but yeah, validity is the key there. You could formulate a general theory, right? And Darwin's theory of evolution is absolutely what we would call a general theory. You do need to know, for all intents and purposes, is that theory is a very high level within science and social science, really. A lot of people think that theory is lower because it hasn't been proven. Actually, the issue with theory is that it hasn't never been disproven. If a theory is disproven, it's no longer a theory and it was a debunked hypothesis. So the issue is between what we get into is theory and law, right? Law is one of those things that all humans recognize as fact, which is fascinating. A lot of people point to the laws of gravity as being fact. Well, the laws of gravity are fact to all human beings that agree on it, right? And usually that's Western and Eastern traditions that are trained in the scientific method. A lot of other people might call it something else, but I just read a recent article on gravity, and it may be that the laws of gravity work in certain locations the way that they're supposed to. But as we move kind of into space in these different locations, gravity might not be acting the way that we think it should in terms of this law. So they're starting to maybe even ask questions about, is the law of gravity an absolute everywhere, right? So then is it a law? So again, we get into kind of semantics, but realize that theory is never disproven. So the thing is with evolution, and again, I'm not going to get into the weeds on people's worldviews or ideology, right? Like this subject can, I don't know, make people, and it did me when it definitely made me a little uncomfortable when I went through this in my first semester, just because my belief structure and where I was occupying and learning all of kind of this information, for me, it was just very foreign, right? I just had never heard it before. So it was, again, like all information, you kind of have to run through the internal dialectic, which is, am I going to accept this information for what it is, and that it's a school and it's a class and I get a good grade, or am I accepting this information as now like part of my identity, right? Which both of those are okay to do. And again, having a little bit of skepticism is part of kind of conflict learning, and some people do very well with conflict learning. But I will point out that the theory of evolution has never been disproven, ever, right? They've tried to disprove Darwin in so many different ways, and it just hasn't. So it is still a theory. Are there things in the video that they're going to actually add to the theory of evolution? Yes, because Darwin kind of misses out on a lot of the mechanics itself, the micro level, and maybe even more the macro, kind of that in-between processual part of it. He misses a little bit with his kind of theories. What I will also say about the scientific method is there is a point where people try to run through this method and it just doesn't work. None of it, right? So they just throw it all out and they kind of just start throwing out other guesses about, or hypotheses about why or what is it and how did this happen, right? And some people probably do this a little bit too fast, which is when you get into people that kind of believe in ancient aliens, right? Like, oh, human beings could never build Stonehenge or the pyramids or whatever else. And we absolutely know that human beings can build those things. We just kind of always have this tempocentricity, which is we're tempocentric, which is we think that our time is the most important and that we're the smartest and that everybody else before us is a little bit dumber, which is just absolutely completely inaccurate and very kind of biased, right? So again, sometimes people do just toss the scientific method and say, you know what, this is beyond our comprehension. We can't even run the scientific method on this, so we're just going to throw all kinds of things out there. And maybe aliens is part of it, or some kind of crazy rogue asteroid or whatever else, right? Like, so scientific method works very well for a lot of instances, but sometimes it doesn't. So there are critiques of the scientific method. So parts of the scientific method, I kind of ran through them all, right? Observation, using your five senses to point out something known or to make known a phenomenon. Ask questions, right? Connecting observations with a phenomenon or larger phenomenon. Testable predictions is a hypothesis. Data is gathering kind of the evidence. Testing is when you gather the data. And then again, empirical, when we get into empirical science, that's verified through observation and experiment. Um, and I these are links to videos on the scientific method. If you guys want to watch some of those, that's fine. You can just kind of YouTube those. But I think most people have a clear understanding. You will be asked on the first quiz to identify the parts of the scientific method, and just and make sure that you know this order, right? Which is observation, question, hypothesis, testing, gathering data, and either you create a theory or you debunk your old hypothesis and start a new one. So that's essentially what you'll have to put on the quiz. There is a scientific process versus the method, right? Scientific process, a lot of times people, again, this is where maybe people use parts of the scientific method in a different processual way. Sometimes people ask questions before they observe. Sometimes people are taking other people's observations. So it's more of a process. It's more kind of malleable and dynamic than just kind of going through this structural kind of binary scientific method. That's the other thing about the scientific method when we start to ask the bigger level questions, quantum physics, some of those, time travel, when you get into some interesting conversations, the scientific method, for a lot of people starts to fall apart, right? I already talked about the facts and the theory. So realize that facts are just something that everybody agrees on. Theory is never been disproven, but not everybody agrees on it, is essentially where we're at, okay? We are obsessed with facts and truths, right? And I would say that what's interesting about that is that all individuals are so subjective, and we have all of our biases kind of coming to the table, but we still are obsessed with the idea of facts and truths, even though everybody's kind of facts and truths are a little bit different. So it's an interesting kind of thing to keep in the back of your head as we move forward in kind of anthropology. All right, so some of the vocabulary that we can kind of run through. Holistic or holism. Anthropology uses this term a lot because it is considered a holistic field, which is the four subfields coming together, right? If I'm going to go off and study a group of people as a cultural anthropologist, I also need to be keenly aware of biology, right? Which is DNA. Why is it that people in the Andes have barrel chests or large lung capacity and are shorter, right? Like those are all things that maybe even start to impact cultural behavior as well. So holism or holistic is the idea of the whole, right? Which is the whole human, everything that the human does, and that is essentially anthropology. A lot of times people also refer to holistic medicine. Holistic medicine is in reference to, instead of treating the mind and the body separate, right? Like Western medicine does, we treat symptoms of the body. We don't really care about the mind. Other traditions, like Eastern traditions, absolutely do not have a dualistic entity around the body. It is holistic, which is they treat the mind and the body as one entity, right? So that's kind of another example of holism. Anatomical, as a term, is pertaining to the organism's physical structure. So when I say, the complete anatomical human, right? We're really talking about the whole structure that exists, and the physical structure. Arboreal, we will use this term. We don't, tree dwelling is what it means. And there's going to be a lot of hypothesis around kind of tree dwelling and arboreal behavior. Terrestrial is life forms on the ground, right? That live on land, not in trees or water. And then morphology is the physical shape and appearance. So anatomical is pertaining to the organism's physical structure, right? Like if I looked at a whole skeleton. Morphology might be kind of my facial appearance, okay? Or any human's kind of facial appearance, or the gorilla's kind of long canines that they have, right? Which are for scaring other males away. They're not actually for eating meat, right? Scientific law, again, is a statement of fact describing natural phenomenon that I would add a caveat that everyone agrees on,